Here's a problem that requires a little bit of decoding because what they're really doing is asking us about a situation where there's a business and we have to read a story about it. So before you even solve this, just realize that it takes a little bit of time to understand what they're asking, especially if you're not familiar with these kind of terms. So we'll talk a little bit about the problem and then we'll work the math out. So it says that for each business day, news reports tell the number of stocks that gained. So here they're defining a term. So a gain is when a stock goes up in price, and the number that declined went down in price. So we have gains, right, where it goes up in price, and declines where it goes down in price. In each of the following pairs of reports, determine which is better news for investors. So the background, of course, is that you as an investor, right, investors want gains. They want the stock to go up, right? Because when that happens, they can sell it for greater value. So they can make money off of it. So gains are good for investors. And in this problem, there are three different situations, A, B, and C. And in each one, we need to figure out what's better. And what I mean by that is it this bracket over here or this one right here? So let's walk through each problem. And the first one says that gains, right, the ratio of gains to declines was 5 to 3. And we want to know, is that better than having a ratio of 7 to 5? So really, in many ways, we're just comparing, right, 5 and 3 and 7 and 5. Let me just move this up here. Well, oops. Okay, so in many ways, we're just comparing these two. And how can we do that? Well, there are many ways. I like this one, though, because if we add up these parts of parts, right, we get 8 here. And what do we get here? Well, 7 and 5 is 12. And what does that mean? Well, in the first situation, there are 5 people out of a total of 8, right, that had a gain. In the second situation, the gains outnumber declines by a ratio of 7 to 5. So 7/12. And this, this part to whole ratio can help us make a percent in each case. So that's one way to compare it. And 5/8 is something out of 100, right? Some percentage of people had gains there, and 7/12 is also some percentage, right? Something out of 100. So how do we do this? Well, in the first situation here, we can multiply both sides by 100, so we get x equals 500 over 8. All I did there was multiply this side by 100 and this side, right? Here the hundreds cancel out, but over here we multiply. In the other fraction, we do the same thing and multiply both sides by 100, and we get 700 over 12, and that equals x. So now it's just a matter of solving these percents. So in the first situation, we have 500 divided by 8, and that's about 62.5%. So in this situation, we have about 62.5%, or sorry, exactly 62.5% of people that had gains. In the second situation, 700 divided by 12, that gives us 58 and a 0.33333, so 58 and a third percent of people had gains. So this just means, of course, that in this situation, it's better, right, to have a ratio of gains to declines with 5 to 3. That's the better situation here. And that was just one way to compare, using percents and proportions. In the next one, we'll use a different technique, right, in part B, just so you can see different ways of solving these problems. So in part B, what does it say? Well, it says gains outnumber declines by a ratio of 9 to 5, or gains outnumber declines by a ratio of 6 to 3. So what's better here? So 9 to 5, right, 9 people who had gains for every 5 who had a loss, or would you rather have 6 people, right, with gains for every 3 people, that had a loss, right? What's the better situation? So now I'm going to just keep scaling up these ratios until I have the same number of people with losses, because I noticed that here we have 5 people with a loss, and here we have 3 people with a loss. I know that those will meet once we have groups in each situation with this proportional ratio with 15 people with losses, because, of course, 5 times 3 is 15. 15 is a multiple of both. So let's scale up these groups. Here we have 6 people with gains for 3 losses. If we double that, we get 12 to 6. And then we have another group of that. We'll have 9, right? And then 18 here. Do it again. We have 12, and this goes up by 6. We get 24. And then 15, right, to 30. So it's 2 to 1. And here, what's happening? Well, same thing, but this time I'll just skip ahead and triple each side. So I get 15 to 27. So what's better here? Well, this time it's better to have gains outnumber declines by a ratio of 6 to 3. And we can see it right here because in the first situation, there were only 27 people for every 15 with a loss. Here there are 30 people with a gain for every 15 with a loss. So more people have gains, right, for those 15 losses. But I guess, there's an even easier way to look at this without setting up this ratio table. I just wanted to show the ratio table. The easiest way I think of looking at this is that in this group, twice as many people had gains than losses. In this group, even without figuring out the exact amount more times that we had gains than losses, I know it's not double, right? Because 5 doubled is 10, and 9 is less than that. So in this situation, we had less than twice as many gains as losses, so it can't be better. And 6 and 3 has to be the better choice. Here in the last one, I'm going to use my ratio table again because it's just not as easy to see, right? The doubling and I could use percents again, but I'm going to go with another ratio table. So this time they're reversing it. Declines outnumber gains by a ratio of 10 to 7. So this time 10 represents the declines, right? D for declines, and 7 represents the gains, G for gains. Is that better or worse than declines outnumbering gains by a ratio of 6 to 4? Well, I'm going to first think about, right, when do these two ratios meet, right? And I think the easiest way to do that is just to keep scaling up these groups. So here, right, we have a group of 10 people, 6 and 4. And 6 had a decline and 4 had a gain. So here we have groups of 17. And that might not be so nice to meet because 17 and 10 meet at a very large product, right? But the number of gains is small, 4 here and 7 there. And those will meet at 28. So a fast way to use a ratio table is to quickly scale these up. If I multiply this ratio, this group, by 4, right? That means what? Well, what I mean is I multiply each part by 4. So I'll have 40 people with declines for 28 with gains. So this is a much larger group, right? This is 68 people here. And here, what I want to do is get the same number, right? The same number of people with gains. And I have a 4 here, so to get from 4 to 28, I scaled this up, each part by 7. So I get 28 over here, 4 times 7, right? That's 28, and 6 times 7 is 42. So notice that there are a different number of people in each group. Here there are 70 people. But this allows us to make a comparison because in each group they're the same number of people with gains. But in this group right here, this time the higher ratio is worse because in this group, even though you had 28 people, right, in both groups with gains, here in this group there are 42 people, which is more than 40. 42 people with a loss. And that's not good for investors, right? There's more losses. Oops. So here I'd say this is the better choice, right? There's less declines for every number of gains, and that's a better thing. All right, thanks.